All right, so let's look at ML100 here. And in here, I'm going to start using Google Colab. This is where everything will be in Python. Like say, this course is pretty much all going to be, all the machine learning models we program are going to be in Python. And you can use any Python environment you like, but I like Google Colab because it's free, and it means that every student has access to the same environment, as opposed to, the worst thing is students that have Windows installs. When they install Python, they get some mess that doesn't work very well. This way, everybody has the same environment, and it's free. So, we're going to use the TensorFlow library here, and I'm following a textbook example here where they worried about what version it is. It doesn't really matter for us, as long as it's a modern version, and it is. But the TensorFlow library is one of the main machine learning libraries, and it's what we're going to use here. So now it'll eventually print up a version number here. There it is. So it's version 2.14, which is fine. So now this is where we can talk about what's really going on here. This is what machine learning is. So if you measure something like a scientist, you have some value x and you measure some dependent value y. So you have various values of x and various values of y. A human can look at this and notice, well, when x goes up by 1, y goes up by 2, and when x is 0, y is minus 1. So a human can figure out the pattern is y is 2x minus 1. And before machine learning, you would just program this equation in a programming language like Python to predict this. But the point of machine learning is the computer is going to figure out that pattern without a human putting it in. And it doesn't take much code to do that. This is enough to do it. So if I put in another block of code, and I put in that stuff, this is going to import TensorFlow and NumPy, and what it's going to do is make a model with one neuron. It's going to use the mean squared error as a measure of loss, and then it's going to do stochastic gradient descent. Here's the data, the x and y values, and it's just going to fit it doing 500 steps of improvement, and then it's going to predict the y for an x of 10, so we can see how accurate it is, because the right answer for that prediction is 19. So if you run this, which is here, it goes through 500 epochs of training down here, and you see a loss number. And this loss number is getting smaller and smaller. Until around 500, it gets extremely small, like 10 to the minus 5. And the prediction has gotten very good. It should be 19, and it's 18.98. So it has gotten quite close to being accurate here. And so what's going on here is we have one neuron, and all it does is a linear calculation on the input. The one input x is multiplied by a slope m and an intercept c to mx plus c, and it's just going to adjust those two parameters to lower the loss. And it starts with random values, and then it figures out what direction would lower the loss and takes little steps in that direction, and after 500 steps, it's gotten pretty close to the minimum, so it's pretty much fit. That's the game here. So now we can see what the network learned here. We can see what parameters it learned if we repeat the process and keep track of more of the parameters in there. So this blob of code will do that. This is going to do the same thing, 500 steps of gradient descent, but it's going to print out the weights. The weights are the parameters, and that should be 2x minus 1. Those parameters should be 2 and minus 1. And you see, here it is 1.99 and minus 0.99, so it got pretty close. It got within 1% of the right values of figuring out the slope there. All right. And now we can add some errors to it. So if I just took the y values and I just added some random noise to it. So if I go back up to my code here, yes, all right. There's 2 scroll bars and I have trouble reaching the right one. try making my window a little wider. There, that might make it easier to reach the right scroll bar. There we go. All right, so there's my code. And instead of using those y values, I'm going to use these ones, and I'll just comment out this line. So you see, it's just, I added a little bit of variation to it. So there's some, yeah.
May I make a comment?
Yeah.
There's a couple of seconds of latency after you post things till we see it.
Oh, if you turn on the Twitch sound, it'll be synchronized with the visual. It's the Zoom sound that's a little bit faster. So that's one way to work around that. But yeah, I could also, let me watch mine and I'll try and just pause enough so it's all right. So here you see, here's the original Ys, and here's the replacement Ys that just have a little bit of variation. And if I run this one, now the loss never gets very small. Before, the loss got down to 10 to the minus 5, but now it doesn't get as small because, of course, with noise in the data, it can't get the loss to 0 anymore. But still, it's pretty good. The 1.99 and minus 0.99, it's still pretty good at fitting data, even with noise in it. Now, if you try to fit something that is not a straight line at all, then it'll fail by quite a lot. So here's some data that's actually a parabola. So if I go back to my code and I put in that data, all right, whoa. All right, now I got to do, there we are. So now this is a shape that is not straight at all. And so the loss is huge, like 76, and it goes down to 5 or 4, but it never gets below 4 because it's just trying to put a straight line through something that is not straight, and it's never going to fit it very well. And now we got one where we can draw the curve so you can see how it works. Somewhat more code. And I'm going to clear off this old stuff, File, move to trash, and then return to Colab is how you get a clean Colab. And new notebook. And now I can paste in this. By the way, there's now Generate with AI inside Colab. I haven't tried using that yet. It might be fun to see how it works. But this model is more complicated. This model has one input neuron. Let me get to see if I have a picture here. Yeah, it's gonna, you see the shape of it is quite complicated. So it has one input neuron of X and one output neuron for Y, and in between it's going to have 2 layers of 64 neurons to do the calculations. So it's a neural net with 4 layers. An input layer, 2 hidden layers doing calculations, and an output layer, and a lot of parameters it can adjust. You can see up here it has 4,355 parameters. And here it is, training for a series of epochs and having the loss go down. And when it's done, it's going to print out the results and a graph. And there it is. And as you can see, the curve fits pretty well through the points, but it's not like using an analytical equation. It's adjusting 4,000 parameters to trace through those points. So it is it has learned that pattern without making any prior assumptions about it. And then there's some flags you can find here by running various variations of this. And you can play with changing the number of hidden layers and the number of units per layer to see how many neurons it actually needs to do a good job of this. So that's a good one where you get to practice setting up simple machine learning and see how it looks in Python. So I'm stopping this one.